So far, we've been looking at the file system mostly from the point of view of programs and the file system API. And now that you're comfortable with that, what I want to do is ask you to think about what must happen between that file system API and the disk interface. In other words, if you think of the API at the top of this picture and the disk at the bottom, I'm asking you what goes in the middle. Right? So at the top, we have the file system API, open, close, read, write. Down here, we have persistent storage, which is just a collection of numbered disk blocks with some error handling. And all we can do is like read and write those entire disk blocks. So those don't really look like files. The question is, how do I get from here down to here? So let's start with our system calls and let's deduce what kinds of things they have to do. So let us start with the open call. And there's really two different things that the open call has to do. On one hand, it has to map this high-level symbolic name to some object, right? Because users think in terms of names and disks think in terms of blocks. And then the other thing it has to do is manage those file descriptors that we've been talking about. So let's start with the first task. We need to somehow map a name to some metadata, right? Metadata is data that describes something, that describes other data. So our file is data and metadata is what describes that file. Now, files live forever. So, or for first approximation, they live forever. That is, when you power off your machine, your files had better still persist. So what about the metadata that describes those files? Well, it had better persist as well. So not only do we need to map the file to the metadata, but then once we have to like figure out where does that metadata live, i.e. in what location on the disk will I find that metadata? And then I have to actually go to the disk and read the metadata. So that's half of what open has to do. So there's really two pieces to it. One is it has to somehow transform that symbolic name to something that the file system can figure out where its metadata lives and then how to get it from the disk. The second thing that open has to do is it has to deal with file descriptors. So when you do an open, I have to figure out, well, what file descriptor should I assign to that file? Where should I set its offset? Like all the things that we're going to need when other function calls or system calls need to access the file, we have to have that all set up so that they can just give us this integer file descriptor and the right things happen. So the data structure that we're going to use to manage our file descriptors, we call the file descriptor table. And as you've seen in previous videos, we also have an open file table and a vnode table as well. But for the purposes of the API, we're going to focus on the file descriptor table. All right, so now that we know that, what does close do? Well, hopefully it's pretty clear that close should just reclaim the resources that open set up. So if you open file descriptor 3, when you close file descriptor 3, I need to go to your file descriptor table and sort of update all the metadata that talks about file descriptor 3. And when I talk about this metadata, not the metadata of the file, but all the data in my file descriptor table that had to do with this file descriptor that I'm closing. All right, so those are pretty straightforward. Now let's look at read and write. Okay, so read and write get a file descriptor. So it should be pretty clear that the first thing they're going to have to do is they're going to have to go and access the file descriptor table with those file descriptors. But then what, right? So I get a file, I go to the descriptor table. What should that point me towards? And what it's going to point me toward is some in-memory representation that corresponds to that object. And for historical reasons, we call that a vnode, for virtual node. So open, close, create the file descriptor table, or create the entries in it and free them up. What read and write do is they then go look something up in the file descriptor table. And what they find there has got to be some way to get them to the in-memory representation of an object. Now, what does that in-memory representation have to do? Well, it has to keep track of a whole bunch of stuff in memory. But fundamentally, one of the most important things it has to do for read and write is that we talked about this byte stream model. So read and write are expressing themselves in terms of offsets in the file. And so one of the key things we need to do between this memory object and the disk is figure out these offsets that we're thinking about in the file. How do they correspond to disk blocks? And so to do that, this in-memory object is going to contain somehow a mapping. And that mapping is going to provide a way for us to go from a file offset to some location on the disk. And so from an algorithmic point of view, what read and write have to do is take an offset, find the right block on the disk, either if it's a read, bring it into memory and then give you some bytes from it. Or if it's a write and you're writing the entire block, then it's take those bytes you wrote and write those into the disk. So what we have is an in-memory representation, represented here by the V node. We have some kind of mapping that is going to map from offsets to disk addresses. And that mapping is what's going to allow us to write to the disk. Now, in reality, the metadata here that I talked about and this mapping is really part of this metadata. And for historical reasons, which will become clear by the end of the unit, we tend to call the structure that we write onto the disk that is the metadata that contains this mapping information an inode. So stepping back a moment, what we have is a bunch of different pieces that comprise a file system. So we have metadata, and in fact, we have two kinds of metadata. We have some metadata that describes the entire file system, like how big is a block for this file system? And then we also have for each file in it and directory or folder, we have information about that object, including this mapping information we talked about. We call that an inode. On the file descriptor side, we have some table that holds file descriptors, and we have code that allocates and frees them. And then we also have some way of mapping those file descriptors to these in-memory objects that we call vnodes. Okay, and a vnode can represent a file or it can represent a directory, and we use the term directory and folder interchangeably. Directory is sort of the historical file system term. Folder is the metaphor that's introduced with the desktop, and so those really mean the same thing. Now we also have to implement this naming. Remember I said we translate a symbolic name to this internal object. So somehow we have some kind of map that takes a symbolic name and gets us to an object. And so we have to figure out how we're going to implement that. And that is going to have two pieces. There's going to be whatever we keep in memory to make things fast, but that symbolic name, again, has to persist even if I crash. So on the disk itself, there has to be that mapping. And so one of the questions we're going to ask is, well, how do we store that mapping to make it efficient? And then finally, we have the files themselves, like how do we store those? And again, we have two problems to solve. One, where do we put the metadata? And where do we put the metadata in such a way that I can find the metadata in order to go find the real data, right? Once I have the metadata, that has that mapping so I can find the disk blocks, but I have to get started and I need some way to get to that metadata. So these are the problems that we have to solve in order to understand what a file system does. So in the rest of this unit, we've already talked about file descriptor management. So next, what we'll do is we'll talk about how we represent files, and then how we use that representation of files to implement this naming. And then what we'll do is we'll show you a couple of different file systems and how they put these things together.